Okay, so let me share my screen. Let me know if you can see it.
Yep, looks great.
Okay, so let's start talking about the Requestor project. This is a project I've started back in 2014. I've worked on it about 2 years. Then I stopped working with different things. And now in 2021 I decided to get back on it, revamp the project, because I see there are some gaps that we can improve regarding the HTTP communication area. So that's it about the project. Let's start here. So what we will see in this presentation, basically two things. One, what is Requestor and why it's unique, some of the unique features this project has. And two, I will give you a glance of a strategy to start simple and consistently grow a front-end application. Okay, so moving on, I don't want to bother you with some personal stuff, but I need to make a brief introduction of myself. So that's my past experience. I started working with programming at the age of 15. I have graduated in computer science, and I've been working in Petrobras, the main oil company here in Brazil, for 10 years. I also had experience as a startup co-founder and CTO, and in the last few years I've been learning project, studying subjects like economics, accounting, accountability, laws, financial analysis, things like that. And I will be starting working as a tax auditor in the next days. In this period, I also had experience working with data science, and I had the pleasure to have a award-winning project in Petrobras, doing some LSTM neural network stuff. I have experience with backend, Java, Node, Python, Ruby. In the front end, I have experience with JavaScript, TypeScript, and Java as well. I had experience with machine learning in recommendation systems and recurrent neural networks. And also, I've done some past work using D3, Power BI, things like that in the business intelligence area. These are some of the topics I have interest on. And also, the main thing I love to do really is to model. So, be it modeling a problem to create a neural network features, or to model concepts and create a software design. These are the things that I really love to do, and one of my strongest skills. Okay, moving on, so let's talk about the Requestor. What's Requestor? Basically, the short description, Requestor is an HTTP client API. Okay, so what makes Requestor unique? You guys might be thinking, what a beautiful slide, right? So I beg your pardon, but I needed to place here some of the main features of the library, and we'll discuss a few things later. So Requestor has a beautiful API. That's one of the strongest skills of the library, and an outstanding usability. So it promotes a very good programming experience for us. Also, Requestor is not designed to thinking on code generation firstly, so not based on code generation. Code generation can be used, but it's the last step in the design decisions. So it's not fault to be using code generation at first. Also, it has a high fidelity HTTP modeling with things like headers, payloads, URIs, links, forms. And I have made a great effort to model such concepts in the library and represent it in the better way I could. Also, Requestor has a great HTTP support, enabling us to really interact with HTTP API. Also, we can have downloaded the progress tracking. It's event driven, We have HTTP polling support by design in the library. It's process-oriented, async first. It's session-based with state management, and we have support to have multi-client sessions and something what I call micro-clients that enable us to really empower the micro front-end approach. Also, we have interoperability with any Java platform. Okay, so moving on about what Requestor really is more deeply. So the long description, Requestor is a session-based, process-oriented, stateful, event-driven HTTP client API that grounds communication-centric apps. So let's dig a bit about those topics. So Requestor is session-based. What it means? It means that to start using the Requestor library, the first thing we need to do is a session. So we instantiate a session, obviously. If we are using a dependency injection system, we will do the required configurations. But here's a simple example. We start a session, and with that session, we can start requesting. So that's the simplest way of doing a GET request using Requestor. So simple like that, you already have done a GET request. Obviously, we are not listening, we're not binding in callbacks here yet, but the request is already being done here. The same way, you can do a post request, sending some object instance, like in this example, we are sending the book instance to this URL. Here an example of binding a callback. So we can make a GET request and ask in the payload of the response a book class. Then Requestor will serialize the response payload to us as a book, and we will receive here in the onSuccess event the book instance, and we can make use of it. Finally, we can also receive a list of books instead of on a book. We can we can request here a set of books as well, and that's how Requestor works. Here we are receiving a list of books. Moving on, so this is the HTTP client, very brief introduction, but Requestor provides us a requesting Fluent API that allows us to really build a complex request and do any kind of communication that may require some more complicated workflow. So to start requesting, we have the rec method. In the rec method, we give the URL, we can give the link as well, and the URI object that Requestor offers to us. So when we call the rec method, we can start building the request with this Fluent API. So we can set a timeout on the request. We can set a delay, so the request is only sent after this delay. So we can also set the content type and the accept headers. So these are some just shortcuts to setting those headers, the most common headers we use in the HTTP communication. Obviously, we can set any other header, either using string key and string value, or using any of the header implementations that Requestor offers to us. So in this example, we have the quality factor header that will build this kind of header, and it obeys the official reference of the headers. Additionally, we can set the authentication method that we want to use, and the Requestor already gives to us the basic authentication, the bearer token authentication, the digest authentication, even the OAuth 2 client authentication, we can use it. Additionally, we can set the payload of the request. Here we are passing a string, but we can pass any object. And the Requestor has a serialization mechanism to properly serialize the payload. Finally, after setting the request options, we must call what we can understand as HTTP invoke methods. So any of the HTTP methods, get, post, put, delete, and so on, we can call here. And additionally, with specifying the HTTP method that we want to use, we can also specify what we expect in the response payload. So here we are specifying that we expect a string in the response payload, but we can use declare here any object, and like you already saw, we can specify a list of a collection of objects as well. And after invoking the HTTP request, we can start binding the events. So when we call the invoke method, we will receive a request object, and the request object is a deferred object, and it allows us to start binding callbacks to specific events. So here we are setting callback to the success event. So if the request gives us a 2xx response, then we will execute this callback. If in contrary we don't receive a 2xx response, but we do receive some kind of response, then this fail method will be executed, and we'll have the row response here. And if we didn't receive any response at all, then this error event will be called, and we will execute it with an exception here. Okay, so that's the basic flow. Like I said, we first start setting the request options, then we call an invoke method, and later we start setting the callbacks for the specific events that may occur. That's the requesting Fluent API flow that Requestor designs. Okay, moving on. Also, the session is configurable, so any of those options here we can set as default in the session. So we can set, for example, a media type that will apply this value as the accept and content type headers. That's a shortcut for setting for all requests. We can set any header that will be applied to all requests in this session. We can set the timeout, delay, any other option like the authentication method. We can set the authentication instance, or we can set a provider of the authentication method. That's a very powerful mechanism, because if your authentication instance it relies on some kind of state, we will probably want to use the provider signature, because you will have a new state for each request. So, and finally, we can always reset the session state if we need to. So that's it about the session. Moving on, Requestor is process oriented. So what it means? It means that Requestor establishes a process stack in which the request will be submitted to. So we have what Requestor calls a request lifecycle. Okay, so that's the basic flow. The user starts building a request and then invokes it. The request is sent to the processing stack of the request. The first step is the filtering process. After the request is filtered, then it's submitted to the serializing process. After the request is serialized, then it's submitted to the intercept process, and here we have a serialized request already. Finally, after being intercepted, the request is then finally authenticated with the auth process. After that, we have a prepared request that can be sent to the network, and after we receive a response from the network, the sponsor is evaluated and submitted to the response processing stack. And the first step is the intercepting, because the response is initially serialized. So we intercept the response, then we submit it to this deserialization process. Finally, the response is already deserialized and is submitted to the filtering process. With the response already filtered, then the callbacks that the user has bound here in this first step, they are executed. Okay, so that's it about the request lifecycle, and we have the option to create filters, interceptors, authentication methods, and in each of those steps, as many as we want. So that's a powerful process that we have very fine control of what a request can be done. Also, we must be aware that each of those steps are asynchronous. So when creating a filter, the filter is asynchronous and so on. So I'll give you a quick example of a filter. So we call a session.register and we create a filter instance here. The same way you can create a provider instead of a filter instance. So we always have this option of setting providers instead of the instance itself. And the filter interface, we receive a request in process object. So the request is in process right now and it's not serialized yet. So what we can do in the filter, we can set a header, we can set an authentication method, we can set a timeout, any request configuration we can do here. Okay, we can also exchange the payload. So the payload is not serialized yet, and we can modify the payload as well. Okay, we can check if the payload is instance of some object and things like that. Finally, we can call the proceed method. Okay, we need to call it actually because it's asynchronous. If we don't, the request will be hanging. Additionally, you can note that since it's asynchronous, we can make any asynchronous processing here. So if you need to call a different process, even a web worker, things like that, you can do it here because this filtering is asynchronous. Moving on, the request interceptor, it's similar to the filter, but the main difference is that we receive a serialized request here. Okay, and being a serialized request, we have access to the serialized payload, and we can exchange something in the payload. Here in this example, we are prepending some safe characters to a JSON, so we can be sure that this JSON cannot be intercepted by a third-party entity or person. Okay, so that's an use case of using the interceptor and modifying a serialized payload. And finally, as always, we must call request.proceed so the request can proceed in the processing stack. Okay, so that's the interceptor, one interceptor example, and that's it about the requesting process. But you need to be aware that we can create as many filters as we want here. We can create as many interceptors as we want in the session as well. The authentication in the request lifecycle, we obviously need to have only one. Okay, the serialization and deserialization process, I won't get deeper here because it's a very deep topic and we don't have time to do it, but you can be sure that Requestor offers a very, very pleasant and easy design to make this kind of stuff. And be aware that we can intercept the request and also the response. So if you need some kind of starting something here and finish something when the response is received, you can do things like that. Okay, so let's move on. We have already talked about the process oriented aspect. Let's talk about the stateful aspect, and that's an important thing of the library. So besides being an HTTP client, the session is also a store, and that's important. So being a store, we can do things like save an object by key, retrieving an object by key as well. Okay. Additionally, we can make some queries like querying if this key exists in the store and if this key is equal to that value. Okay, so we can do some queries. We can remove the object associated with this key, and we can also clear the store, removing all objects that are saved in the store. So that's it. That's important that we know that the session is also a store. And besides the session, the request is also a store, but the request is like a child store of the session. Okay, so the request store has an independent context from the sessions, and we can do something like that. For example, we can register a filter, and in this filter we can check if there is some object associated with this key, and if this object is true, for example, right? And if it's true, we can set some header, we can do some stuff. So we are querying the store, the request store, and we are doing some custom logic and proceeding with the requesting processing. And what's happening here is that we are querying the request store first initially, okay? And if this key is not found in the request store, then residually we are querying the session store, which is the parent store of the request store. Okay, so what's happening here is that, for example, if we do a request like that, we can, while building the request, we can save an object in the request store. So we are saving the true Boolean value associated with the private key, okay, and then we are sending the request. When we do it, we are saving this value in the request store, okay, not in the sessions. And what will happen is that in this filter we will have this private as true, so this method will be true, and we are going to execute this custom logic here. So that's it about the request store. And also, like I said, the request store accesses the session store. So for example, here we have an authentication method. I haven't talked about the authentication interface yet, but basically we have this auth method, and we receive a prepared request like I showed you in the processing lifecycle. And what we are doing here in this authentication method is that we are querying if there is a logged user in this request store, and if there's a logged user, we retrieve this user information, and we set the authorization header using the token that's already saved in the store. Finally, we call the request.send. Okay, and what will happen here, for example, suppose that we call session.request in the login URL, and we set the credentials that we received from the view, and we are making a post receiving a user info class. If this request succeeds, then we can access the request. So besides the user info, we have the response and the request I will talk about later, okay? But we have access to the payload, to the response, and to the request object. So in this example, we are calling request.save when we receive the login information. If the login succeeds, we save the logged user info in level.root. What is happening here is that we are saving not in the request store, but since we call it to save in the level.root, we are saving in the root store that this request is associated to. Okay, so in this example, the root store of this request is the sessions store. So this logged user info will be saved in the sessions store. And in this authentication method here, for the next requests, what will happen is that this if will succeed because there will be a logged user in the session store, and we will set the authorization header. So that's it. Additionally, we must be aware that the auth method is also asynchronous, so we can perform an asynchronous process here and finally send the request. Moving on, besides the store aspect, the stateful aspect of the Requestor library, we also have the event-driven aspect, and I have already given you a glance of it, but let's dig deeper. So Requestor defines some events, and that's important, and I'll talk later why I didn't choose to use promises and why I didn't choose to use observables and the reactive approach. So first, let's see about the events. So these are the events that we have in the request library. Do you guys hear me well? Sorry.
Yeah, I'm just hearing Frank occasionally getting some audio, and we're trying to mute him.
No problem.
But his meet keeps unmuting himself automatically. And I don't know why.
Let's move on. So that's the events. The blue events are like success or not success, but events that are triggered if we receive a response, and the red events are events that are triggered if we don't receive a response. Okay, so let's talk about those events first. The parent event of an event that may occur and do not allows us to receive a response is the echo event. And the echo event has three child events, which is the abort event, the cancel, and the timeout. So the abort event will be triggered in time before the request is sent. So for example, during the processing stack, if some error occurs that blocks the request to proceed in the stack, we can reject and we can abort the request. There is a method to do it, and we call request.abort instead of proceed. The request will be aborted and the abort event will be triggered. Additionally, if the request is actually sent through the wire, but some error occurs, like a network error, something like that, then the cancel event is triggered, and we can listen to this specific event as well. Finally, if no error had occurred but the timeout has expired, then we will have the timeout event. So we didn't receive a response yet, and this is a timeout. This is an error event and not a load event. Okay, and the error event is the parent event of those three. So besides listening to the specific events, we can also listen to this broader event that will allows us to listen to any of those events in just one method. Moving forward, and once we receive a response, the response will be submitted to the processing stack of the response, and finally the response will be resolved. Okay, like I said, it's a deferred object, so the deferred will be resolved, and when the deferred is resolved, we trigger the load event. So the load event will give us access to the actual response, and additionally the request, I will show you later. But it's important that you guys note that Requestor models each status code as an event. So if the response was 213 is an event. Additionally, any status family is also an event. So if the response was 213, for example, the status family event will be 2, right? If the response was 429, the status family will be 4. And a Requestor offers those two broad generic load events, which is the success and the fail. The success is if the response is from the two stats family, the success stats family, and the fail is if the response is not from the success stats family. Okay, so that's it about the events that we have. Additionally, we have the progress events that I will show you in a moment. So let's see about the events that we have. Like I told you, once we do a request, we have access to a deferred request object, and we can start binding callbacks to the events. So let's see here. In this example, we are binding callback to the success event, to the fail event. Like I told you guys, in the success event, we have access to the payload already deserialized. We have access to the response and also to the request. All those three arguments are optional, so we can bind a callback to listen to receive only the body, the payload. We can bind a callback to receive the payload and the response, and as a third option, we can bind a callback to receive the body, the response, and also the request. So that's a functional aspect of the library that's really great to have a better programming experience. Moving on, we can also listen to specific status, like I said. So the 429 is a specific event that you can listen to. We can optionally use the status enumeration in the Requestor library, and this status enumeration is very full-featured with all status that may exist in the HTTP context. And also we can list to specific status families events, like the server error, which is in from the 500 family. We can listen to the client error, which is in of the 400 family, and so on. And on those status callbacks, we receive the response and also the request. You guys may notice that when in the response object, we can have access to the payload, okay? And later I'll tell you about if this payload can be deserialized or not. And it can, but it's a different topic. Moving on, we can also listen to the load event, which is the generic event, the parent event of those events here that we just talked about. And the load event is whenever we receive a response, be it 200 or not, whatever. So any response that we may receive, we can listen to this event as well. Moving on, we have the progress event, so we can listen to the download progress event and the upload progress event, like I said in the initial slides. And those two events, they are called many times during a request, okay? With progress of the event from 0 to 1 or 0 to 100% if you prefer. Also, we have the error events, like I told you, and in the error events we receive an exception. So in the timeout event we receive a timeout exception, the cancel event we receive a cancel exception, in the abort event we receive a abort exception, and we also can listen to the parent event, which is the request exception, is the parent exception of those three exceptions here. Okay, so that's it about the events. And we finished talking about what Requestor is. Okay guys, I would like to open for questions, but I feel that I don't have too much time and I need to move on. Okay, so let's talk a bit about what is the idea of communication-centric apps. So communication-centric apps is something that I'm advocating and something that I have practiced in the past, and I feel that's a good path. I'm not saying that's the only one, but it's a good path of building front-end applications. So what's it? The communication-centric idea for front-end applications, okay, not for server, is that we have the communication process in the core of our front-end software, okay? I haven't talked yet about what is a service for you guys because we don't have time to do it, but as a service, you may, in a brief, you can understand it as a subsession, and a subsession that has some amount of application logic and specializes the communication with a specific feature of our server, or specializes the communication. So it's like a subject-oriented client, okay? And it's important to note that it has some amount of application logic as well. So the idea of communication-centric apps, like I said, is having the communication in the core of your front-end application. So using Requestor, it would mean that we have the session in the most inner part of our architecture. Around the session, we would have services. Like I said, the services, they are subject-oriented, so they can be oriented for an entity, for a family of remote procedure calls, things like that, okay? And around the services, we would have the UI. So the UI is the yellow part here, and we would have components associated, consuming, composing the services, okay? And that design allows us to grow our application, for example, having sub-components in this D component here down below. We can have specialize the components in sub-components and moving on. And one of the important parts is that besides having the subject-oriented aspect here, because of the services, we also have Requestor have the state management capability. So here in the upper left, we can see that we can exchange data from the components to other components, and also from the components to the services and the session. And that's important because it allows us to have a communication between components in a decoupled way. Okay, so a component in the right here, for example, can consume some data from that was produced in a component in the left here in a different subject, and things like that. So also we should be aware that when exchanging data, we would always have the thinking of not exchanging every data that the component produces, but only the necessary amount of information that we need to move to the more inner part or to the more root level of our architecture. So always have this feeling of what I really need to share and what's not necessary to be shared. Okay, so that's it about the communication-centric idea, and we can talk very more things about it, but that's the general idea that I can show you right now. Moving on, let's talk a bit about the design philosophy of the Requestor library. So we have three main pillars, which is interoperability, simplicity, and extensibility. Okay, about the interoperability pillar, Requestor is implemented in vanilla Java 5 in the core. So it had all the features that Requestor provides, they are implemented in vanilla Java 5. I decided to let in vanilla Java 5 because it will have a broader compatibility with other languages and other Java platforms, and that's good, that's important. And also besides that, for the implementations of the library, we have only two requirements: to have implementation of Requestor for a different Java platform like Android or Git or Kotlin JS, any other Java-based platform. So the requirements are those: just implement a sync scheduling and a network operation of sending the request and receiving the response. So that's the only two abstractions that we need to implement to have a Requestor fully working implementation. So that design decisions allows us to have compatibility within Java platform and potentially with other languages as well, other small talk inspired languages like Java. Briefly, what we need to do to implement Requestor for a different platform is implement those two methods here, the schedule run, which receives a runnable and needs to schedule this runnable with this given delay. That's basically it. In Git, for example, we use the site timeout JavaScript function. In Java, we use the pool of threads, and we can schedule the thread to be running in this delay. And the second method that you need to implement is the send method. When we receive the prepared request with all the information that the user has give to the request when building, we have the default that we need. It allows us to either reject the default or resolve the default. Okay, so that's the basic steps that we need to make. First, try sending the request. Then, if some error occurs, we reject the default with a request exception. So we have the abort exception, we have the cancel exception, and the timeout exception. We can use one of those three. And also, if we receive a response, we resolve the default, building our response with the information that we got from the specific platform that we are using. Okay. Basically, that's it to have a fully working implementation of Requestor in any platform. Moving on, about the simplicity aspect. So I really make a great effort of promoting a beautiful API and a very pleasant API to use, because I like to have a better programming experience. So the simplicity aspect of the design pillar is it's about it. We have the Fluent API. We have complex features that are made very simple to the library user, and the library is functional. It's Lambda friendly. Okay, like I said, we have optional parameters and things like that when creating lambdas. And so one example of complex feature that was made simple is the HTTP polling. So to have a polling request, we only need to call this poll method. In the poll method, we need to pass a strategy, an interval, and a limit. And let's see an example here. For example, when doing this request to a real-time endpoint, we just set this poll method when making the request, and we set the polling strategy, be it short or long. Short is the next request will be triggered after the previous one was sent. So I'll talk about the long polling later. So that's it, and we set the interval. So we will have a request being sent in each 5 seconds, and we have the limit number here. So we have this request will be sent in each 5 seconds for 10 times at most. So that's it, and when we call this request like this, the success method here, it's an event, right? So the success method can be called 10 times because the request will be called 10 times. So that's one of the reasons why I decided to use events and not promises. Okay, so the event can be triggered not only one time but many times. A different example here, we have the long polling strategy, and the long polling strategy basically is a new request will be sent when the previous request has a response received. Okay, so here we didn't set an interval and we didn't set a limit. So in this example, a new request will be always sent whenever we receive a response. Okay, and in the success method, we can also access the request and call the stop polling method. So we have control over the polling flow, and that's very good. That's important. We can access how many times the request was polled and things like that. Okay, so that's a complex feature that was made simple in the Requestor library. Also, we have the retry function that is also complex, and it was made simple. I don't have time to dig deeper on it, but basically what we have to do is give a sequence of delays, and Requestor offers this delay sequence factory that allows us to create sequence of delays. In this example, we have 5 seconds in the first retry, then we'll delay for 15 seconds in the second retry, and finally we'll delay for 45 seconds in the third retry. So we will do at most 3 retries here. And after setting the delay sequence, we also set the events that will trigger a retry. So for example, if the request triggers a timeout event, instead of triggering the timeout error, it will initially retry after 5 seconds, then for the next delay sequence, the next delays in the sequence, until finally the timeout event is triggered for the user. So that's the flow. So besides having this fixed sequence, we can have geometric sequences and arithmetic sequences. So this will be a geometric sequence starting from 3 with a reason of 2 to the limit of 4. That's basically it. And also be aware that any status is also an event, and any family is also an event. So we can specify any status and status family or any other request event, and that's it about how we can specify a retry policy in Requestor. Okay, so it's very flexible and it's very simple to the user, like I said. Moving on, the extensibility pillar. I do not have time to dig deeper on it, but Requestor has a design principle of favoring good design instead of code generation. And what it means is that any feature that is thought to be implemented in Requestor, we do not think in doing code generation at first. Code generation is always the last option. So what it means is that we always have like interfaces and abstractions that favors code composition, favors inheritance for the user. So that's important, and like you guys have already seen, we have a very pleasant programming experience with no code generation at all. Okay, obviously if something demonstrates to be repetitive for the user side, we can use code generation, but it's not the first option. It's not designed for it. Okay, so that's it about the Requestor design pillars, and we are moving to the final part of the presentation. Some of the roadmap of the library. So what needs improvement? The logging of the library needs improvement. I need to show on the parts that need logging. Also the Java docs, I need to better document the classes and interface and things like that. We have tons of use cases to build recipes, okay? Because of the process aspect of the library, the async process, the async aspect of the library as well, and the things that you have already seen, the communication-centric idea, the services that I didn't have time to talk about here. So there is a ton of recipes that can be written to demonstrate use cases of the library. The project site needs improvement. The showcase application needs improvement. I don't know if you guys have already seen, but there's a showcase application. Also the code quality of the library, the code quality tool needs some improvement as well, and the building tool, because I'm using Maven because it's an old project and I think it would be good to move to Gradle in the future. So that's it about what needs improvement and some of the planned features. This is the final slide. I have already plans of creating store events. So currently we cannot listen to events in the stores, but I will implement to listen to the save event and the remove event, and that's important to improve even better the stateful aspect of the library. And also setting expected types by response status. So when building a request, we set the expected type for the successful stats family, but I have already experimented, and setting expected types for a specific code status or specific status families different from the 200 in the session configuration. Okay, so that's important because we can model error message in the backend, and in the front end we always have this message deserialized as the expected type that we defined. That's very good. Also, we have the option to persisting the stores, so creating persisting backends, like for example if you are using browser, you can persist with the I forgot the name, the IndexedDB and other things like that we have in the browser to make a persistent data. Also, if we are using Android, we can persist with SQLite and things like that. So having persistent backends to the stores, it's good. Also, having side-light payloads deserialization, that's very good as well. When working with Django, I had experience of working with side-light payloads. It's similar to what is a GraphQL API does, and I have planned how to do it in Requestor. So for example, we can request not only one entity in the payload, but we can request like a map of entities by keys. Okay, so this is what we would have a side-light payloads. For example, if the user belongs to a group, we can specify to have the user in the user key, and the groups, a list of groups in the groups key. It's similar to it. Side-light payloads. If you guys don't know, you can ask me. Moving on, we can have partial chunking events. So instead of the progress event, I have a plan of switching to the read and write events. So in chunk of bytes that is written, or that's read or that's written in the connection, we can have access to it. So that's my plan of switching from the progress to this read and write events. And obviously the impulse that we can have for Requestor, so for Android and JVM, for Jekyll, for Kotlin JS, using transpilers, we can have implementations for TypeScript and also for Dart if it's possible. So that's it, guys. Thank you for your time. Thank you for listening to me. And now we are open to questions if you guys want to know something deeper about what I have told.